Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, it's Mr. T with a follow-up tutorial on simplifying expressions using exponent properties. I'm just providing some more examples to augment the earlier video that you watched. So let's go. So here's our first problem, and we have a expression inside of a parentheses with a power. So we're going to use our power to a power rule. So we have to do a couple things. We have to apply this exponent of 3 to each of the terms, the -3, the u, and the v, inside the parentheses. And secondly, when we apply the power to a term that already has an exponent, remember from our exponent properties we will be multiplying. So for our first step, expand this, we're going to have -3 raised to the third power. And then we're going to have u to the -4th raised to the third power, and v to the third power raised to the third power. So now we have to simplify these. As we said, we're going to multiply these exponents. So we have u to the -12th power, and here we have v to the 9th power. And now we want to expand this. So the 3 here cubed would be 3 times 3 is 27. And now we have to deal with this negative. So remember, if we have a -1 to an even power, so an even number of negatives, we get +1. And if we have -1 to an odd power, we're going to end up with -1. So this is a negative to an odd power, so we have negative. And finally, remember, we're not allowed to leave our final answer with any negative exponents, so we're going to make this as a fraction, and then anything that has a negative exponent, we move to the bottom. Now remember, we're not moving this 27 with that. When we're dealing with exponent properties, the coefficient in front is separate from the variable. This coefficient has an invisible exponent of +1, so there's no need to move it. Remember, when we move it to the other side of the fraction, we change the sign of the exponent. So our final answer, I'm going to bring the negative out front, is going to be 27v to the 9th in the numerator, and in the denominator we have u to the 12th power. So again, that's our final answer for this problem. So let's look at the next one. Okay, in this one we have fractional exponents, but the properties for fractional exponents are the same as when we have integer exponents. So maybe we might want to approach the numerator here and simplify the numerator. So we've got the constants which we want to pair up. So we have 3 times 4, that's 12. And we have a's to pair up. Now when we multiply two items with the same base, we add their exponents. So we have -3/2 from this first term plus 3/2. And then we pair up the bases of the b's. And our exponents that we're going to add are 3/2 and plus a -1. And I'm going to leave the denominator alone for a second. So if we do the arithmetic of our exponents on the top, we've got a to the 0 power, and b 3/2 minus 1 is 1/2. And on the bottom we have our a to the 1/4 and b to the 5/4. So remember, a to the 0 power is 1, so we have 12 times 1, so that just disappears. And now we are going to combine our b's. Now we could move this a to the top, but when we do that, we're going to be subtracting it, and then we're going to move it back. So since we only have a single a, let's leave that in the bottom. But here we need to combine those. When we combine those, we're going to get, since this is division, we'll be subtracting the exponents. So 1/2 minus 5/4, 1/2 is 2/4, so we get b to the -3/4. So let me just go ahead and show that here. And finally, we need to move the b to the denominator to have it be a positive exponent. So we end up with, that's a 4 there, and then b to the negative 3/4. Not negative 3/4, when we move it to the bottom, is now a positive. That's our final answer here. So just work it step by step, pairing up bases and using the appropriate rules, adding exponents when we're multiplying, subtracting exponents when we are dividing, and at the end, anything with a negative exponent goes to the other side of the fraction. Now let's look at a different type of example. This one, when we start out, we have what's called radical notation. So we have this square root symbol, but in this case we have a root number here. So this is actually not a square root, it's a third root or a cube root. And the key to working these problems is remembering that the nth root of some expression is equivalent to that expression raised to the 1 over n, or 1 over the root power. So if we expand what's inside the parentheses here, we've got 5r to the 1/3 power, and that whole thing is raised to this 4th power. Now we have our power to a power property, and remember on that we multiply our exponents, so we're going to take 4 times 1/3, which gives us 5r to the 4/3 power. Now we could possibly distribute this 4/3 to the 5 and the r, but if we raise 5 to the 4/3 power, that's an irrational number. We don't get a whole number, so we'll just leave it in this form here, and that would be our final answer. So hopefully these extra examples help you when you're working the worksheets in class, and best of luck.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you